Welcome to Chem Time.
Welcome to the presentation. I start the presentation by highlighting the importance of today, that is 8th June. In the year 1955, on 8th June, Sir Tim John Berners-Lee was born. And Sir is known for his invention on World Wide Web, HTML, the URL system, and HTTP. Welcome to the presentation. In this presentation, we are going to discuss the application of the thermodynamic processes that have been developed in the last presentation. And these problems are taken from recently concluded IIT JEE examination. The problem is 1 mole of a monoatomic ideal gas undergoes the cyclic process JKLMG as shown in the PT diagram. And there are two lists given, list 1 and list 2. We have to match the options given in list 1 with that of list 2. There are 4 choices given. Now, first of all, let us break down the processes. MJ and KL both are isothermal. In case of MJ, it is isothermal expansion, and in case of KL, it is isothermal compression. And for isothermal compression or expansion of an ideal gas, the change in internal energy is 0 because internal energy of an ideal gas depends only on temperature. And for cyclic process also, the change in internal energy is 0 because internal energy is a point function. JK and ML are isobaric processes. Isobaric means constant pressure. JK refers to isobaric heating and LM refers to isobaric cooling. Since the gas is said to be monoatomic, that is, the specific heat at constant pressure for monoatomic gas is given by 5 by 2R, that is 2.5R. And since for ideal gas, Cv is equal to Cp minus R, the Cv can be calculated as 5 by 2R minus R, that is 1.5R. The change in internal energy for the process Jk, which is isobaric, is represented as delta U Cv into T2 minus T1. T2 is the temperature at K and T1 is the temperature at J. With this, delta U will be 3 or T0. KL is isothermal process. For isothermal process, delta U is equal to 0. That is Q plus W is equal to 0 as per first law of thermodynamics. That is Q is equal to minus W. For isothermal compression, the fixed temperature of 3T0 from P0 to 2P0, the work of compression is 3RT0 into ln 2P0 by P0. With this, W will be 3RT0 ln 2. Since Q is equal to minus W for isothermal process, Q will be minus 3RT0 ln 2. The change in internal energy for the process Mj is 0 because Mj refers to constant temperature process, and for constant temperature process for an ideal gas, the change in internal energy will be 0. Now, for complete cycle process, delta U is equal to 0 is equal to Q plus W as per the first law of thermodynamics for a closed system. That gives rise to W is equal to minus Q. The Q for the overall process includes the Q for Mj, Q for Jk, Q for Kl plus Q for Lm. Some of these will get the W for the overall process. So that is minus RT0 ln 2P0 by P0 plus Cv into 3T0 minus T0 plus 3RT0 ln 2P0 by P0 plus Cv into T0 minus 3T0, which gives rise to 2RT0 ln 2, and as a result the W will be minus Q, so minus 2RT0 ln 2. And in the options given, the correct option is P is 4, Q is 3, R is 5, and S is 2. So the correct option in this problem is B. The second problem that is given in IIT JEE 2024 examination is, consider the following relation between volume and temperature for the expansion of 5 moles of an ideal monoatomic gas. The gas is ideal and monoatomic. And the process is represented as X, Y, Z. And the gas constant is given as 8.3 and Cv is given as 12 joules per mole Kelvin. And we need to calculate the enthalpy change for this process. Now, as we see, the process XY is constant temperature process, that is isothermal. And for isothermal process of an ideal gas, the change in enthalpy becomes zero. So henceforth, the enthalpy change for the overall process XYZ is the enthalpy change for the process YZ. So for the process YZ, the enthalpy change is given by delta H is equal to NCP delta T. N is number of mole, which is 5. Cv is given as 12, and as per ideal gas law, Cp is equal to Cv plus R, that is 12 plus 8.3 joules per mole Kelvin, into the temperature difference, that is 415 minus 335, that is 80 Kelvin. So as a result, the enthalpy change will be 5 moles into 20.3 joules per mole Kelvin into 415 Kelvin minus 335 Kelvin, that is 8120 joules. With this, I conclude my presentation.
Request you to like, share, and subscribe my channel.